When we think about that probability that I kind of snuck in here, the probability of none of event E, I should have said in n trials, we can see it's getting a little tricky because it uses the complement rule and the multiplication rule. And now we're going to kick it up a notch even further with the probability of at least one. Because we're going to use the probability of none that we just learned how to do, which is the probability of not e to the n power. Which I should actually say that over here. Here, let me put it right here. So this is the probability of none of event E in n trials. So we take the probability of none of event E in n trials and we subtract it from 1 in order to find the probability of at least one of something. So this is extra tricky because we need the complement rule to find the probability of none. Then we need the multiplication rule, and then we need another complement rule. So it actually uses two complement rules and a multiplication rule, so it makes it extra tricky to use. That said, it's on your formula sheet. You don't have to really memorize it in so much as you have to know how to use it. But this is how you find the probability of at least one of event E, right? At least one of something out of n trials. Okay, so let's look and see what the heck we're talking about. So we're going to, again, imagine our card deck. We're going to draw two cards at random. So there's the number of trials right there. I can see that n is equal to 2. And I'm going to do it with replacement, of course, because that's the section we're in. We're not going to do it without replacement. So we know that this is going to be multiplication rule okay. Right? They're independent. So yay, that's good. And the multiplication rule comes into it with that n power bit. That's actually the multiplication rule kind of hidden in there. So what is the probability that at least one of these two cards that we draw is a king? So there's the magic phrase, at least one. So I want the probability of at least one king. All right, that is one takeaway something, and I can tell it's to the 2 power because that's my index, right? That's the number of cards I was drawing. So n is equal to 2. Now the tricky bit is I have to figure out this probability of E complement to put inside there, right? I have to find the probability of none. All right, well, let's see here. The probability of event E, the probability of a king. So let's just figure this out over here for one card. The probability of a king for one card is 4 out of 52. Oh, that looks like an H. It was meant to be a K. There we go. There, I made it better. All right, so the probability of not K is 1 minus 4 out of 52, which would be 48 out of 52. There's 52 cards, 4 of them are kings, so 48 of them are not kings. So that's the number that goes in over here, right? So we just kind of figure this out on the side. We don't have to, well, we want to put it into the problem, but it gets confusing to try to do it all at once. So you do one card over here, probability of king, probability of not king. You're basically trying to find the probability of the E complement bit without the rest of the stuff. And then you're going to go put it in. So you're going to take the probability of not king to the 2 power, which is 1 minus 48 out of 52 to the 2 power. And then we can just go put this into Desmos, right? That's what it's for. So we don't have to figure this out. So 1 takeaway, 48 out of 52. Now the 48 out of 52 I want to raise to a power, so I'm going to put parentheses around it, and then I'm going to raise it to the power with the A to the B button, and then hit the 2. And I can see it's 0.1479. And if I want the fraction, it'll tell me it's 25 over 169, but it didn't ask me for that. Oh, 25 over 169. I don't know if I said that, but 0.1479. All right, so let's go back and look, and there it is. All right, let's do it again. So, all right, we want to draw 4 cards when with replacement. So 4 cards is important because now I know my n equals 4. With replacement is important because otherwise this rule doesn't work at all, right? So n equals 4. And I know it's with replacement, so I know it's independent. That's good. We don't actually work with things that are not independent as a general rule, with the exception of the two-way table. Okay, what is the probability of at least one spade, right? This one was a king, now we're looking at spades. So the probability of at least one spade will be 1 takeaway. Then we'll have the probability of not a spade in here. So we've got to find that probability of not spade. That's key. So let's go over here and figure this out. But only for 1 card, right? We're not going to try to deal with the 4 cards thing. That gets too confusing. So I want the probability of a spade. There's 13 out of 52, which is 1/4, right? 1/4 of the cards are spades. So the probability of not getting a spade is 1 minus 13 out of 52, which is 39 out of 52, or 3/4. So that's what we'll go put in. And you can put in either one. It doesn't really make any difference. So we'll take 1 minus, and I'll do the harder one. I'll do 39 out of 52 to the 4th. And again, it's to the 4th because there are 4 cards drawn at random here. Okay, so we'll go grab Desmos, and I'll just type it again. 1 minus parentheses 39 divided by 52, close parentheses, to the 4th. And just in case you were curious, there you can see, whoop, I did it wrong. 3/4 is what I meant. 3/4 to the 4th. There we go. Right, because you have to do the probability of not being a spade. There are 3/4 of the cards are not spades. So you take 1 minus 3/4 to the 4, which is 0. Oh, I didn't grab the fraction. I don't think it matters, but just in case you're curious. It's 175 over 276. Which is 0.6836. So to make it clear, you have to use the complement rule once to find the probability of not spade. Use the multiplication rule to raise it to a power, and use the complement rule again to do 1 minus. So these problems are particularly tricky because you're using actually 2 complement rules, and you don't want to get them confused. You do it once for a singleton, a single trial, and then you substitute that value into the formula at the top of the page for the 4 trials that you're doing. Right? So 1 minus appears here and 1 minus appears here. That's what makes these extra tricky.